Hey everyone, this is part 2 of combinations of functions. Okay, so what I've done is, for the sake of time, this is asking us to combine the function g and the function f, and notice that we're given an input. Okay, so that's a value for x. So what I'm going to do is, instead of 3, I'm going to do replace that with an x, and then once I simplify all of this, I'm going to substitute for x in each one of these, whatever we see x. Okay, so again, don't forget the minus means there's a -1 implied in front of that parenthesis. There's a -1 in front of that parentheses that needs to get distributed. So I'm going to write that -1 just so that you see it. And all this is going to do is it's going to change the sign of all the terms that are inside of this parentheses. So then this is equal to 2x minus 3 minus 3x squared. And then this is negative times negative is positive, so that becomes positive 5x, and -1 times positive 4 is -4. So then this is equal to, I'm going to bring these 3x's to the front, so negative 3x squared, then combine 2x and 5x, so that's plus 7x, and then -3 and -4 combine to -7. Now I'm going to substitute for x. So then this is equal to -3, open parentheses. We're being given that the input is 3. So instead of x, 3 squared, and then plus 7 times 3 minus 7. Okay, so this part is 3 squared, that's 9, right? And I'm going to just write this down, and I hope I'll explain this to you in the classroom if you don't understand. Okay, when you take the square of 3, that becomes a 9. Then you're multiplying -3 times 9, which is -27. And then plus 7 times 3, that's 21. And then minus 7. And when you combine -7 and -27, that's -34. And -34 plus 21 is equal to -13. So this is the answer to that problem. Okay. Again, if this didn't make any sense to you, then ask me in the classroom and I'll explain further. So the next example is the same idea. So what I am going to do is, I'm going to add the two functions together. So I'm going to replace this with an x. So then I'm going to do g of x plus h of x. Okay, so instead of g of x is 2x minus 3. Okay, that's what we're given. So we have 2x minus 3. Plus h of x is 3x plus 1. But since this is addition, we do not have to worry about, these two terms changing sign. So then I'm just going to combine like terms. 2x plus 3x combine to, let's see, that's 5x. And then -3 and plus 1, that's a minus 2. So then what I'm going to do next is substitute for x. So this is 5 times 1/3 minus 2. So this is 5/3 minus 2. This 2 is implied to be a 1. Multiplied by 3/3. So we have the same denominator. So then this is equal to 5/3 minus 2 times 3. That's a 6/3. So then 5 minus 6 is 1. So this is -1/3. And that's the answer to that example. For the next part. The next part is actually very simple once you learn how to read the table. Okay, so what this is asking is add f and g. So this is the table for the function f, and this is the table for the function g. So find f of 2. So find f of 2 in the function f, and then find g of 2 in the function g, and then add them together. Okay, so for this one, let's find f of 2. F of 2 means where x is 2. So the input is 2. What's the y value? The y value is 5, right? So then this is equal to 5. And then let's find g of 2. And then look at the function g, where x is 2, which means where the input is 2, what's the output? The output is 7, which is the y value. So now let's find f of 2 plus g of 2. You just add 5 plus 7, which is equal to 12, and that's the answer to that problem. Okay, all right, next example. So for this one, g minus f of 3. So again, now we look at the function g first. So let's see where g of 3, what is the y value at g of 3? So this is the function g, the input is 3, the output is 8. And then let's find f of 3. So for this one, where x is 3, y is 6. So then g of 3 minus f of 3 is equal to 8 minus 6, which is equal to 2. And that's the answer to that one. Okay. All right. So what if they give you a graph? It's the same idea, but instead of looking at tables, you're looking at the graph to get the information. Okay. So let's look at the next two examples. So let's find f of -6, and then let's find g of -6. Okay. So where x is -6 on the graph of f of x, which is this one here. So x is -6. Notice, I know it's hard to see it, but this is the lighter chart is the one for f of x. So then where x is -6, to get to the graph, this is 1, 2, 3. So the y value is +3. Okay. Now let's look at the function g. So this is the graph of g, the one that's dotted. So where x is -6, to get to the graph, we go up 1, 2, 3, and 4. We get to the graph, so that means the y value is 4. So then all you have to do is take, let's see, f of -6 plus g of -6 is equal to, f of -6 is 3, and g of -6 is 4. So then 3 plus 4 is 7, and that's the answer to that problem. Okay, one last example. What if instead we're being asked to find f of g minus f of 8? So then let's find g of 8, and then let's find f of 8. Okay, so on the function g, which is again a dotted graph, look at where the value of x is 8, and that's here. To get to the graph, we go up 1, 2, 3, 4. So g of 8 is 4. Now let's find f of 8. This is where x is 8. We see the graph right on the x-axis, right? So that means the y value, which is the output, is 0. So then let's do g of 8 minus f of 8, which is equal to g of 8 is 4 minus g f of 8, which is 0. This is equal to 4, and that is the answer to this problem. I'll see you in the classroom. Thank you for watching. Bye-bye.